When we're looking for the equation of a tangent, first we need to find the slope of the original line. So the slope of the first one's 3. And then we'll find the slope of the perpendicular line. It's going to be negative 1/3. All right. Second one, the slope of the line was 1/2. So the slope of the perpendicular line is going to be negative 2. So it's negative reciprocals. That's how you'd find the slope of these types of lines. All right, negative reciprocals. So now, this first problem, we would say f of x, this will just be our perpendicular line. Well, actually, we'll call it something else. We'll call it g of x. Just so that way I'm not using the f of x, which is already defined as something. So we'll say negative 1/3 x plus b. And this is where that x and y point comes in. We would substitute it in and say 2 equals negative 1/3 times 6 plus b. And on this one over here, we would say negative 2x plus b. And again, plug in the 2 and the 6. And we'll solve for b on these ones. So the first one's going to be 2 equals negative 2 plus b. Add 2 to both sides. b equals 4. On the second one, you're going to get 2 equals negative 12 plus b. Add 12 to both sides, and you're going to get 14 equals b. So your equation for the function on the left, g of x equals negative 1/3 x plus 4. For the second one, g of x equals negative 2x plus 14. That's how you'd find an equation of a tangent line when you're given a point specifically. Not a tangent line, I'm sorry, a perpendicular line. We're doing this because we're dealing with tangent lines today in class. That's why I brought this up for the warm-up. All right, so any questions on problems 1 or 2 there from the warm-up? Okay, good. So what we're going to start with today, hold on, just saying it. Part B says find the derivative of f of x. So that's where we want to find f prime of x. So hopefully we're good at this by now, identifying derivatives of these types of functions. I mean, it has been a long weekend, so maybe we've forgotten a little bit. But we're going to multiply each function by the power and then reduce each variable by 1 degree. So this was x squared, now it's x to the first, and we multiply by 2. This was x to the first, so we multiply by 1 and make it x to the 0 power. So we should end up with something that is negative 0.04x plus 3.4. And then the next part says find the gradient of the tangent at the point where x equals 50. And we kind of talked about this last week. Whenever you're looking for the gradient of the tangent, that's when you're solving for the derivative. So if I gave you the gradient of the tangent, that means we already have the derivative solved for. But if I don't give you that, that means we're looking to solve for the derivative right now. So we go ahead and say f prime of 50 equals this, 0.04 times 50 plus 3.4. And put that into our calculator. We should get 1.4. And then part D says find f of x when x equals 50. So that means we're going back to the original equation now. We're going to say f of 50 equals negative 0.02 50 squared plus 3.4 times 50. And that's what we would do for this last problem. And we get f of 50 equals 120. And then the last part says, find the equation of the tangent at x equals 50 and sketch this on the graph. So we want to find the equation of the tangent line. So the equation of the tangent line is going to be that y equals mx plus b. All right. So we already know the 120 because we just solved that. That's a y value. So that's what the y is going to be for this equation. It's going to be 120 equals, and we already know the x value is 50, and we know the slope of the line is 1.4 because we solved for that already above as well. So that's where the 1.4 comes in. The 50 was what we were given as x equals 50. And then we're solving for just the b. And in this case, we end up getting b equals 50. So the equation is y equals 1.4x plus 50. That's how you write an equation for a tangent line. So there's a lot going on there. But remember, we have open notes when we're on assessments and things like that. Speaking of assessments, we're going to have our assessment before winter break. So this Friday would be my guess for assessment day. So just keep that in mind. But that's the idea for this type of problem. We want to draw that equation, and now I can just graph it. So graph y equals 1.4x plus 50. And throw that in my graph, and it's going to give me the tangent point somewhere over here around 120, or not even 120. It's going to give me a tangent point somewhere over here. Like when y equals 120 about. And that's what our tangent line is going to look like, something like that. I don't have the most accurate sketch, but we'll just add the tangent line to it. Okay. That's the idea for this first example today. So finding the derivative, hopefully we're not bad at that. Finding the gradient of the tangent line, not too bad. Part D, find f of x. Hopefully that's not too bad for parts B, C, and D. The tricky part, I think, there is part E, finding the equation of the tangent line. I think that's kind of the hard part, and that's kind of the new part today. All right, find the equation of the tangent line at that point. There's a lot of stuff to plug back in there. All right, and that's kind of the tricky part. All right, so one thing that we're going to talk about today is when we're looking at the derivative. So the derivative of a function. At a point on a graph represents the gradient of the tangent of that point. So it's the derivative represents the slope of the tangent, and that's what we just found right here. That's the slope of the tangent. Which is why it's right here. All right. So the derivative at a point represents the slope of the tangent. And then the other thing that we need to keep in mind is there's something called the normal line. That's what we're going to talk about next. And the normal line is perpendicular to the tangent line. And that's what we're going to look at next. Sometimes we have to find a normal line. A good example of what a normal line is, your textbook actually has a pretty decent example of this. But a normal line, the idea is if we had something like, let's say, they use a bike wheel. So we'll say a bike. And then you have, like, let's say this is the road. And this line right here represents the tangent line. Okay, so your tangent line is the road is just touching the bike wheel at one point only. And then you have something that comes perpendicular to it, and that's the bike spoke. The bike spoke, and that's also the normal. All right, the normal line. Because it's perpendicular to the tangent line. All right. So that's something that would be considered normal to the curve because it's forming a perpendicular line to the curve being the bike tire itself. So anything that you can draw that forms a essentially perpendicular angle to the tangent line of the curve. All right. It wouldn't technically be perpendicular to the curve because the curve's always turning. It would be perpendicular at that one point on the curve, and that's why there's a tangent line there. All right, that's kind of the idea here for what a normal line is. Okay. So one of the reasons we did the warm up, find the equation of a perpendicular line, is because that's how we're going to do it. If we can find the equation of the tangent line, we can find the equation of a normal to the curve as well. So it says find the equation of the normal to a curve with this equation at the point where x equals 1. All right. So what we're going to want to do first is find the derivative. F prime of x. So 2x cubed, that's going to be 2 times 3 x squared plus 3 times 1 times x minus 2 times 0 times x to the negative 1. So that becomes 6x squared plus 3. Oops, that's x to the 0 now, so it's plus 3. That's the first step. Next step is find f prime of 1. We have that x equals 1 here. So we're going to plug in 1 and solve. So 1 squared is 1. Let's see. And then we're going to get 6 squared. 6 times 1 squared plus 3 is 9. All right. So now, what the 9 tells us, this is the slope of the tangent line. Is 9. Well, the slope of the normal line is going to be negative 1/9. Okay. So that's how we'd find the slope of the normal line. Now we want to say, let's find the equation. So we'll say y equals mx plus b, where we know the slope is negative 1/9. We already found that part. And we know the x value of the original graph was x equals 1. How would we find the y value for the original function? What would we need to do there? We'd actually need to go back to the original function and plug in 1 as well. So we get 2 times 1 cubed plus 3 times 1 minus 2. And we'd get f of 1 equals 3. So I'm going to give you guys a second to catch up. Sorry, I'm going kind of fast. I don't want to go too fast. But what happens is we find the point of the original function, and we find the point of the derivative at that same value, 1, 9 for the derivative, 1, 3 for the original function. And what that does now is that allows us to say, let's plug in 3 and 1, and we can solve for the b value, and this is going to be the equation of the normal line. So I get 3 equals negative 1/9 plus b, add 1/9 to both sides, and 3 is the same as 27/9 plus 1/9, so it's going to be 28/9. So b equals 28/9, and now I can write my equation. Negative 1/9 x plus 28/9. There's my equation of the normal there, the normal line that goes through the point 1, 3. And I found that point 1, 3 because of I was given the x equals 1, so I can solve for the 3 pretty easily. And then I have to solve for the derivative and the slope of the tangent line by plugging in that point in the derivative equation. All right, that's the idea with this particular problem. So it's like a lot of steps, but we want to find the derivative and then the value at that point on the derivative. And that's going to give us the slope of the tangent line. And now we can find the normal. So there's like a lot of steps there, but hopefully it's not too bad if we have open notes and we're able to go back to these and see what we're doing on them. Okay. Example number 5. This is a good IB question where they give us some variables. So the gradient of the normal to the curve with equation f of x equals kx cubed minus 2x plus 1 at the point 1, b is negative 1/4. So they gave us the gradient to the normal. So the slope of the normal curve, you have to know what that means. All right. So I'm going to write that down. Slope of normal curve, of normal, is negative 1/4. That means the slope of the tangent line is going to be going to be 4. And that's important because that tells us whatever the derivative is at the point 1, all right, so f prime of 1 is going to equal 4. Okay, this is where we're kind of putting it all together, all of our knowledge together. Saying, hey, we found the slope, we know the slope of the normal line, so let's find the slope of the tangent line, because that's going to be equal to our derivative at the x value of 1. All right. Now, for this problem, I have to find the derivative first. So if I did f prime of x here, I'd say 3 times k x squared minus 2. everything else is going to go away. And now, because I already know this over here, f prime of 1 equals 4, I have an x value and a y value to plug in. So I can say 4 equals 3k times 1 squared minus 2. Using that knowledge to plug in and solve for k now. So 4 equals 3 times k times 1 minus 2. Add 2 to both sides, I get 6 equals 3k. Divide both sides by 3. And I'm going to get like k equals 2. That's the first part. Once I have k equals 2, now I can go ahead and, once I have k equals 2, now I can go ahead and say I need to solve for b, which goes back to the original equation. So let's see, I'm going to do this. So now back to the original equation. I can plug in for 2, for k. 2x cubed minus 2x plus 1. And I'm solving for f of 1. I'm just solving for the y value at this point. And I'm going to get 2 minus 2 plus 1. So 2 minus 2 is 0, plus 1 is 1. So that means b equals 1 then. So my k value equals 2, my b value equals 1. But that's a great example of an actual IB exam type question. All right, dealing with something like that where we have to work kind of backwards to figure it all out and put it all together. All right, but we can solve for one of the variables, then solve for the other one. That's the idea here. Okay, last thing today, the last part will go pretty fast, but if we need a little breather, we can take a breather. For number 6, I want to write it as y equals x plus 2 over x minus 1, provided that x does not equal 1. But what we want to do for this one, because I have this whole x minus 1 in the denominator, if I were trying to find the derivative of this, it gets real nasty. It's like x plus 2 times x minus 1 to the negative 1 power. And we haven't talked about doing the derivative for whole quantities like this yet. And we're not going to talk about that, because that's where derivatives get really difficult, is when we start dealing with big fractions like this. It's not a simple one where we can just rewrite as the negative 1 power and then work with it. So the best way to solve this type of problem is to actually graph it. And then we're going to find the slope of the curve at the point x equals 2 and x equals 3. I do have the instructions for doing this in your graphing calculator on the Canvas page. So I put example 3 graphing calculator problem on the Canvas page and example 6 graphing calculator problem on the Canvas page. And
we're not going to know how to do this if we're not testing, is that right?
I'm sorry?
We're not going to have to be able to do that if we're not testing, right?
Well, I mean, I'll still probably ask a question on the next test, just find the slope of these, but all you have to do is plug it into your calculator and find it.
Okay.
Yeah. Yeah, so that's the idea with these problems. So you should be able to graph the function x plus 2 over x minus 1, and then in your calculator there was that apps button. Second program number 5, and then you just type in x equals 2, and it should give you an answer for the slope of the curve at that point. And then you just take the y value. and that represents your slope. So the slope is going to be -3 for one of them, and for the other one it's going to be -0.75. But yeah, it's going to be press second, program, and then 5. And that's going to be how you find your tangent function. All right. And then you just type in x equals 2, and that's how you're going to do it for the first one. And then you do it again, x equals 3. And that's how you do it for the second one. All right, so your assignment tonight, exercise 12C, just the odd problems. And then exercise 12D, number 1, A through C. 12D is literally just what we just talked about for example 6. Really weird functions where I'm not going to ask you to find the derivative of because they can get really, really tricky really fast. So just the first 3, go ahead and type them in and look for the tangent at x equals 3. So those 3 should go really fast for you. Not a lot of work needs to be shown there. But for exercise 12C, there are a few that are going to ask you to find the derivative and find the points like what we did on these examples 3, 4, and 5. All right, that's the idea for the assignment tonight.